The only thing that makes Laplace transforms of trig function piecewise thingies particularly annoying is that ultimately you're going to end up with something like this. It's sine of, or the Laplace of the sine of t plus pi. And you're going to be like, but that's not in my trig table or my Laplace table. Of course not, because you should be able to transform that. And by should, I mean like should, like you should floss every day. Or you should, you know, like exercise and stuff and not sit in front of YouTube all day and do math. Except you should do that, because that's fun. So anyway, the idea is you should be able to look at that and go, well, that's just the same thing as a Laplace of negative sine of t. Because if I graph it, if I graph sine, like it looks like this, but if I shift it over by pi, then it looks like, because that's pi, if I shift it to the, well, this is really shifting it to the left, so if I shift it to the left pi, well, it still looks like this, which basically means it just looks like the opposite, except I really am not good at drawing stupid things like this. So now if I get rid of the whatever thingy, now that's just negative sine of t, so you should theoretically be able to do that. So really I just wanted to take a minute and practice doing a couple of those so you get the feeling for it. So basically, like if we have sine t plus pi over 2, again, so you kind of think, all right, so I've got my sine function, and every pi, you know, it crosses over and stuff. So it's like this. So that's every pi. I'm going to do some this way. Every pi, it crosses over. All right, so then it's t of pi plus 2, which means it's actually being shifted to the left by a half of a thingy. So basically, instead of going on the green marks, it's going to hit on the red marks. So it's really going to go like this. Oh, except I'm really bad at drawing because it's right in the middle. It's going to go like that, and that, and that, and that, and that, and that, and that. Okay, which is really hard to see until you get rid of the little blue line and you go, oh, wait a second, I know what that is. That, do you know what it is? I'll give you a second to figure it out. Pause the video if you think you got it. That's cosine. Okay, so basically the idea is if you are able to do this by graphing, some people have like this thing where they like go like this and they just know, and that's never made any sense to me, so I don't teach that because I try not to teach things that don't make sense to me. But anyway, so let's do another one. Let's do sine of t, say minus pi over 2, and that'll pretty much get you through everything, on sine at least. So you can say, okay, well, again, here's my standard sine, and every pi it's going to go through. So every pi it's going to go cha-choop, 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 cha-choop. If you already know what this is, you can go ahead and fast forward a little bit. I'm really not trying to bore you. Now, so it's going to be shifted over to the right pi over 2, which means now it's going to cha-choop like this, and cha-choop like this, and cha-choop like this, and stuff. And then like this. And you go, okay, well, I'm going to erase the stupid green line. And maybe some part of you goes, oh, that's just negative cosine. Like that. Okay, so a little positive negative cosine. So we'll do the sines, and we might as well go ahead and do through the cosines just for fun. So if you want to finish this out, obviously, if I shift sine backwards or forwards by pi, I'm going to end up with negative sine again. So I don't even know if I want to bother doing that. So okay. Another way is to get super duper desperate and just say, I'm going to remember my trig identities. It just depends on how desperate you are in what way. So if I have sine of A, cosine of B, sine B, cosine of A. So for example, in this one of these up here, if I had the sine of t plus pi over 2, I'd be like, okay, so that's the sine of t, cosine of pi over 2, and then the sine of pi over 2, cosine of t, and then you go, okay, sine of t, cosine of pi over 2, 0, undefined, so that's 0, and then sine of pi over 2 is 1, cosine t, so that's just equal to cosine t, which is in fact the same thing that we got. And you're like, I thought this was supposed to be about Laplace of piecewise functions. I know, I'm getting there. But basically just trying to remind you that you can do these any way that you want, but this will be an important part because you can't take the Laplace transform of the sine of a plus b, you have to break it up into the two parts. So again, just to remind you what those trig identities are, so remember that this is a plus or minus, so accordingly, then you have cosine of a plus or minus b, cosine a, cosine b, minus plus, so if it's plus then you go minus, if it's minus you go plus, sine a, sine b, however you want to do it is all that matters as long as you just eventually do something. Alright, so which is what we're going to do now. So let's say we had a function in terms of t. It was equal to sine of t for t between 0 and pi over 2. And it's equal to cosine t. Why would someone do this? I don't know. To impress somebody. Because they weren't hugged enough as a child. Because they're bored on a Saturday night and just decided to make YouTube videos. I don't know. Why does anyone do anything anymore? Okay, so there we go. T greater than pi. Alright, so the next step is going to be to write this as a piecewise function. So if you haven't already had enough practice of this, I recommend pausing the video and seeing how far you can get. So basically I want the sine function times the top hat that goes from 0 to pi over 2. And then I want cosine t minus 3t, sine t, times the top hat that goes pi over 2 to pi. And then I want to add something you can't see, times this thingy, like that. And I will make it smaller so you can see what I'm doing. Doo-doo! No, that did not do it. Doo-doo! Doo-doo! There we go. Okay, so that's fun. So that's going to be sine of t times the unit step starting at t minus the shifted unit step, t minus 2, or pi over 2, and then this thing, this thing, this thing, u t minus pi over 2, minus u t minus pi. You see all these things are coming in? This is just obnoxious. Why would anyone do this? I think we already answered that question. U t minus pi. Yay! Okay. And then I'm going to simplify this because I have nothing better to do. So that's going to give me unit step times sine of t, and then u of t minus pi over 2. Let's see, it's going to be sine t, I'm sorry, minus sine t plus cosine t minus 3 sine t. So that's going to be times cosine t minus 4 sine t. Oh, this is going to be so much fun to take the inverse Laplace transform of. And by so much fun, I mean bleh. Okay, plus u of t minus pi. And let's see, that's going to be minus cosine t plus 3 sine t plus 3 cosine t, so that would be 2 cosine t plus 3 sine t. And if that doesn't get you excited, I don't know what does. Actually, be a little surprised. It's hard to get excited about things that require trig identities. I don't know why. It just is. But now let's say I want to take the Laplace of this thingy. And I'm trying to get it all together so you can actually see what's going on. I just don't know if that's going to be possible because this is kind of an obnoxiously long problem. Okay, so instead of just saying equals, let's go to equal sign, and we'll just say, I want to Laplace this. And you can't see the whole thing, but we'll get close. So, there we go. We're going to Laplace that gigantic thing. Now, fun. Okay. So, Laplacing the first one. Sine, Laplacing a sine, I can do that like nobody's business. Because if I Laplace the sine of t, and because it's just the unit step, it's just times 1, that's going to just equal 1 over s squared plus 1. Technically 1 squared. That's cool. All right. Now, I'm going to go ahead and zoom in because I need space. I need space to do math. Okay. So in this first guy, our tau, so for this section here, tau is going to be equal to pi over 2. Okay. Our g of t is cosine of t minus 4 sine of t. And this guy's already up too high. I think I do this every time, but you know, that's all right. So, whoa, go back. So I've got g of t plus tau has to equal cosine t plus tau minus 4 sine t plus tau. Okay, now I can make things a whole lot better by simplifying this. So we come to this above. I'm going to get minus sine of t. Okay, and then I've got minus 4, and then this one is going to be positive cosine of t, just like that. Okay, so essentially what I'll then have here is e to the minus pi over 2 times times the Laplace of negative sine t minus 4 cosine t. All right, plus, whew, this is all kinds of exciting. Now this guy, in this section, our tau is going to be equal to pi, and our g of t is equal to 2 cosine t plus 3 sine t. So g of t plus pi is 2 cosine t plus pi, 3 sine t plus pi. And I can use whatever method I want to simplify it, and ultimately I'll get 2 times negative cosine t and 3 times negative sine t. Okay, so that means that it's going to be e to the minus pi s times the Laplace transform of negative 2 cosine t minus 3 sine t. Now I can zoom out so you can see the whole thing again of what it all turns out to be. Okay, so that's nice. So now I can go ahead and just finish off the Laplace transforming, pi over 2s, and heaven knows, so that's minus 1 over s squared plus 1 minus 4s s squared plus 1. Well, this isn't too bad. This isn't scary at all. E to the negative pi over pi s times negative 2s s squared plus 1 negative 3 s squared plus 1. And if I get super excited about simplification, I can combine some of those terms. E da 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 da. I'll put the minus sign out there. And then I'll have 4s plus 1 s squared plus 1 e to the negative pi s 3, or say 2s plus 3 s squared plus 1. And then we're done. See? Not so bad.